Hi everyone, in this video I am going to solve Cambridge International AS and A-Level Mathematics Paper 2, Pure Mathematics 2 in a session May-June 2025, Paper 2-5. So let's start with the first question. Question number 1, show that this integral equals to ln A, where A is an integer to be found. Okay, so how do we integrate it? 8 is a constant. Take it out from the integral from 2 to 11. It's a definite integral. It has upper limit 11 and the lower limit is 2. So it is 1 over 4x plus 1 dx. Okay, now we know that the integration of 1 over x dx is equals to ln x plus some constant of integration if it is indefinite integral, but it is a definite integral, so we are not adding the constant of integration. So we have 8. Now this is ln of 4x plus 1, and the derivative of 4x plus 1 is just 4, so 1 over the derivative is 4, and the limits are from 2 to 11. Alright, now for this simplification, 4 times 1 is 4, 4 times 2 is 8. So the simplified form is 2 natural log of 4x plus 1, and we need to substitute the limit from 2 till 11. Right, now in the next step we have to apply limits. Applying limits. Okay, so when we apply the limits, the upper limit is 11 and the lower is 2. So 2 natural log of 4 times 11 plus 1 minus 2 natural log of 4 times 2 and plus 1. Upper limit, subtract the lower limit. So we have 2 natural log. 4 times 11 is 44. 44 plus 1 is 45. Minus 2 natural log. 4 times 2 is 8. 8 plus 1 is 9. Alright, now we can take 2 common and we are left with natural log 45 minus natural log 9. Now we have to use a property of log. When two logs are subtracted, it means we have to divide. 2 is outside, and then we can say natural log of 45 divided by 9. And we know that 9 times 5 is 45. Okay, so this becomes 2 natural log of 5, but we need to figure out the answer in natural log of a. There is no constant multiplying with the natural log, so you have to shift the number which is multiplying before the log to the power. So this is natural log 5 to the power 2. So this is natural log of 5 square is 25. Now this is in the form of natural log of a, where a is equals to 25 is an integer. Alright, now this is in the exact form we need to figure out. Natural log of 25. Question number 2, part A, sketch on the same diagram the graphs of the absolute function and the linear function. Okay, right. Let me show you guys the sketch of these two functions separately, and then I will sketch on the same diagram after. So the first function is y equals to absolute of 2x minus 9. We can open the absolute as y equals to plus minus 2x minus 9. So here we have two functions, y equals to plus of 2x minus 9 and y equals to minus of 2x minus 9. So this function is y equals to 2x minus 9, and this function is y equals to minus 2x plus 9. Now this is in the form of y equals to mx plus c form, right? The slope intercept form. The slope is 2 and the y-intercept is negative 9. The slope is negative 2, the y-intercept is positive 9, right? Okay. Let me sketch these two. You can use a method of slope intercept method to graph these two linear functions, or you can use a method of x and the y intercept. Both methods are correct, right? So I will sketch this with the first method and this with the second method to show you guys how to sketch the linear function with two methods, right? So for this function, let me solve for the x intercept. For x-intercept, you have to put y should be equals to 0. When y value is 0, we can say 2x minus 9 equals to 0. So 2x would be equals to 9 and x would be equals to 9 by 2. And what is 9 by 2? I guess it's 4.5. 9 by 2 is 4.5, yes. Okay, so the x-intercept is 4.5. Now solve for the y-intercept. For y-intercept, you need to put the variable x should be equals to 0. So when x value is 0, we have y should be equals to 2 into 0 minus 9. So the y-intercept is negative 9. The y-intercept is negative 9. The x-intercept is 4.5 for this function, right? Okay, now for the second function, I will use a second other method, slope and intercept method, y equals to mx plus c, right? Where c is y-intercept. So here the c value is 9. So 9 is the y-intercept. And we can say m is the slope. So the m value is negative 2. And slope formula is rise over run. So we can say this is minus 2 over 1. We can write it down minus 2 as minus 2 by 1. C value is 9 and M value is minus 2. C is your y-intercept. Now the y-intercept is 9 and the slope is minus 2 by 1. Let me sketch these two on the same axis. Okay. The x values we need are positive and the y values here is negative, right? Okay, so we need the scale by 3 or 2 is better, right? This is 0, okay. This is 2, 4, 6, 8. And if I move up a little bit and down a little bit, now this is 2, 4, 6, 8, and 10. Here we have 9, right? And in the bottom again, we can say minus 2, minus 4, minus 6, minus 8, and minus 10. Here we have negative 9 because the y-intercepts are negative 9 and the positive 9. Okay, and the x value is 4.5 on the other side. This scale is also, you have to fix the scale. This is 2, 4, 6, 8, 10. Minus 2, minus 4, minus 6, minus 8, and minus 10. Right. Okay, now for the first function, I'm using with the red one, this function, right? Y equals to 2x minus 9. The y-intercept, x-intercept is 4.5. So here we have 2, 4, 4.5. This is the x-intercept. And the y-intercept is negative 9. This is your negative 9. Let me sketch this. Connect these two. So this red one is a graph for y equals to 2x minus 9. Okay, now the second function, I'm using this with the purple one. Okay, now this function y equals to minus 2x plus 9. So the y-intercept is minus 9. A positive 9 is the y-intercept and the slope is minus 2 over 1. So rise can be up or down depend on the sign, and run is left or right depend on the sign. Now the rise is 2 units and it is negative, so move 2 units down. Okay, so this is 9, 1 unit and 2 unit down. So we are at number 7. And you have to run 1 unit to the right. Now we have at number 1. 7, 1 and 7. This is your second point. Okay, connect these two. Okay, this purple one is a graph for y equals to minus 2x plus 9. Okay, now for the absolute value function, what is the graph for y equals to absolute of 2x minus 9. So as you can see, the y function is absolute, means it's always positive, right? So the y's are always positive. So we are not considering the negative values of the y. So we are not considering this part of the graph, just this v-shaped graph is the absolute function for 2x minus 9. Let me sketch this separately. Okay, this point is 4.5 and this point is 9. Just a rough sketch. This is the v-shaped graph. Okay, this point is 9, this point is 4.5. Okay, so we have done with the first one. Now for the second graph, we have 4x minus 5. This is again a linear function. You can use any method, the slope intercept method or the x or y intercept method. I showed you both of the methods. Find the x-intercept, y-intercept, plot both of them, you will get a straight line. Or you can figure out what is your y-intercept, what is the slope, rise over run, or use that one, right? Okay, let me sketch both of them on the same axis now. Okay. All right. Now, let me draw the coordinate axis. You can make it till 10. 0 till 10. 5 is the middle one. Or we can start it from here. That's fine. Okay. Now we can say the y values. This is 0, 2, 4, 6, 8. We need 9 and we have 10. And downward we have -2, -4, -6, -8, and here we have -5, right? Okay, now for x values, this is 2, 4, 6, 8, 10, -2, -4, -6, -8, and -10. All right. Now we need to sketch the first one. The first one we have already done. This is 4.5 and this is 9. Okay. So let me sketch 4.5 and 9. 4.5 is in the middle of 4. This is 5 and this is 4.5, right? And this point is 9. And the bottom point is -9. Okay, where is -9? -9 should be somewhere over here, right? So this is a sketch for the V-shaped graph is for the absolute function. Because the bottom one, you guys can see the y-intercept is -9. So I fixed below -8, it's -9, like this. Let's say here is we have -9, right? Okay, it's just a sketch, not the exact one, right? Now for the second one, here we can use a method of x and y-intercept and the slope method, right? So for this function, the slope is rise over run, which is 4 over 1, we can say, and the y-intercept is -5. Okay, so the y-intercept is -5. So from -5, you have to run 4 units up. So 4 units up. 1 unit, 2 unit, 3 unit, and then 4 unit. Okay, so from you are at -1, 4 units up and run 1 unit to the right. So at 1 -1, this is your second point. This is the curve. The pink one is for y equals to 4x minus 5, right? Okay, now they have one point of intersection only. So first you need to plot y-intercept, which is -5 downward, and from y-intercept you have to rise 4 units up. 1 unit up is -4, 2 unit up is -3, 3 units up at -2, and 4 unit up is at -1, and run 1 unit to the right. Right, so when you're moving around here, this is 1. So 1 minus 1 is your second point. So this is your curve. Now for part B, solve the inequality when this absolute is less than 4x minus 5. Alright, so in this question, first we need to find out the point of intersection of these two functions, the absolute value function and the linear function. As you guys can see, this is the absolute value function and this is a linear function. They have only one point of intersection. And what is their point of intersection? When the negative of this absolute means minus 2x plus 9, this function, as we have done this. So this line is basically for minus 2x plus 9, right? So when the negative of this absolute intersect with the linear function, you will get some point of intersection, right? So first we need to figure out the point of intersection of absolute of 2x minus 9 equals to 4x minus 5, put them equal. So they have only one point of intersection, and when they have a point of intersection, when this linear function y equals to 4x minus 5 intersect with this part of the curve only, not with this one. So y equals to 2x minus 9, not with 2x minus 9, with negative of 2x minus 9. Okay, so it is with negative of 2x minus 9 equals to 4x minus 5. I hope this is clear why I put the negative sign, because you can see with the negative of absolute function, we have the point of intersection, not with the positive one, right? Okay, so here we have minus 2x plus 9. This would be equals to 4x minus 5 minus 2x, and shift the 4 on the other side, minus 4x. This would be equals to minus 5, and shift the 9 on the other side, it becomes minus 9. This is minus 6x, and in 9 when you add 5, this makes negative 14. So negative is cancelled with negative. X would be equals to 14 divided by 6. 2 times 7 is 14, 2 times 3 would be 6, and the x is 7 by 3. Okay, so what is 7 by 3 in terms of decimals? 7 by 3 is 2.3. Regarding, okay, so they have the point of intersection, which is 2.333. Let me label this. Their point of, this is the point of intersection. This point of intersection is 7/3. Okay, so the absolute function and the linear function intersect at this point, right? Now we need to figure out when this absolute function is less than this linear function. Okay, so the absolute function, this absolute part of the absolute function is less than this linear function when you put the values of x, which is more than 7 by 3 or less than 7 by 3. This is we need to figure out, right? Okay, so when we put the values which is more than 7 by 3, we can check. More than 7 by 3, if I can take 4. More than 7 by 3, 7 by 3 is 2.3. If I can take 4. So if you put the value 4, so the absolute function 2 into 4 minus 9, this is -1, and absolute of -1 is just 1, right? And on the other hand, 4 times 4 minus 5, this is 4 times 4 and minus 5, 11. This is 1 and this is 11, so 1 is less than 11. So it is proved that all the x values are more than 7 by 3. If you take the values which are less than 7 by 3, let me check at 2. 2 times 2, 4. From 4, take away 9. We have -5, and -5 absolute is +5, right? And 4 times 2, 4 times 2 is 8, and 8 take away 5 is 3, right? So 5 is less than 3? No, it's greater than 3, right? So this implies absolute of 2x minus 9 is less than 4x minus 5 when the value of x, when x should be greater than 7 by 3. right? So we need to verify this. Let me verify this. When x is greater than 5/3, so we can verify. So let me pick the value which is x is greater than 7/3. So we can say let x is equals to 4, if you can take 4, because 7/3 is 2.3333, so we can take 4 and check the inequality, this one, right? So absolute of 2 times 4 minus 9 is less than 4 times 4 minus 5. Okay, now 2 times 4 minus 9, this is minus 1, so absolute is just 1, is less than 4 times 4 minus 5 is 11, so 1 is less than 11, so this is true, right? Or on the other hand, if you can take x values which are less than 7/3, 7/3 is 2.33, so its less value is 2, we can take, right? So we can take let x is equals to 2 and check this absolute inequality, right? So when x value is 2, so the absolute of 2 times 2 minus 9 is less than 4 times 2 minus 5, right? 2 times 2 is 4, and 4 take away 9. 2 into 2 minus 9 is minus 5. Absolute, its absolute is 5, is less than 4 times 2, 8. 8 take away 5 is 3. Is 5 is less than 3? No. 5 is greater than 3. So then equality is not valid when you take the values of x less than 7/3. So then equality is valid when you take the values of x which is more than 7/3. So this is the value of x which satisfy your inequality. So you have to solve this question with the help of the graph, because we have given the graph. So as we can see, this part of the absolute function only has a point of intersection with this linear function, right? Not this one. And it has only one point of intersection. So the first thing is to figure out that point of intersection. And then you have to check that if you pick the values more than that point of intersection, whether the inequality is valid or not, or pick the values which is less than that point of intersection, whether the inequality is valid or not. Then we can check with both of them, and it is verified that when the x values are more than that point of intersection, this inequality is valid. Now for question number 3, find the coordinates x and y of the stationary points of the curve with equation y equals to this. There must be more than one stationary points, right? Because it says points, x and y, both coordinates we need to figure out, right? So as we know that for stationary points, we need to put the first derivative equals to 0, right? We can say dy over dx should be equals to 0. This is your y. Now let me differentiate. Now here we apply the quotient rule. So the denominator function square, denominator function is as it is. The derivative of the numerator function 8x derivative is 8 minus the numerator function, and the derivative of the denominator function is only 2. Minus 6x derivative is 6 and 5 derivative is 0 equals to 0, right? Constant derivative is 0, minus 6x derivative is minus 6, and here I apply the quotient rule. Okay, now we can do further simplification. 2 times 8 is 16x, and 3 times 8 is 24. Minus 2 times 8 is minus 16x. Whole thing divides 2x plus 3, its whole square, minus 6 equals to 0. Now with positive 16x and negative 16x, these two things are cancelled out, and we are just left with 24 divides 2x plus 3 whole square minus 6 equals to 0, right? Now we need to simplify this further, so we can say 24 minus 6 into 2x plus 3 whole square divides 2x plus 3 whole square equals to 0. Now this denominator multiplying with 0 is 0. We are just left with 24 minus 6 into, open the square, a plus b whole square. So 4x square, 3 square is 9, plus 2 into 2x into 3. 2, 2, 3 would be 12x plus 12x. This would be equals to 0. Now 24 equals minus 6 times 4 is also 24x square, and minus 6 times 9 is minus 54, is constant, this is with x, and minus 6 times 12x, 6 times 12 is 72, minus 72x. This is equals to 0, right? This is with a plus, so a plus b whole square, and everything is now minus, right? Minus 24x square minus 72x, and what is 24 minus 54? Minus 30 equals to 0. So we can take negative sign common and divide it by, now every number is divisible by negative 6, right? So minus 6, minus 6, minus 6, and minus 6. Okay. 6 times 4 is 24. 6 times 12 is 72, which we have done. And what is with 30? 6 times 5 is 30, equals to 0, right? Now this is a quadratic equation in x, right? We can factorize it or apply the quadratic formula. Let me do the factorization. 4 times 5, which is 20. Factors of 20, 2 times 10 is also 20. And when you do 2 plus 10, that is equals to 12. So we can break the midterm with 2 and 12. 2 plus 10. 4x square plus 2x plus 10x plus 5 equals to 0. Now taking 2 and x common, we are left with 2x plus 1. And let me take 5 common. 5 times 2 is 10x plus 1. So both the factors are same. So the factors are 2x plus 1 and 2x plus 5 equals to 0. Now put separately, the both factors separately equals to 0. 2x plus 1 would be equals to 0, and 2x plus 5 would be equals to 0. And from here 2x is negative 1, x would be equals to minus 1 by 2. And here 2x equals to negative 5 and x is equals to minus 5 by 2. These are the two x coordinates of the stationary points. We need to figure out the y coordinates by substituting these x values into the equation of the curve. Right. Now here we can say put x coordinates in equation of the curve. Equation of curve is y equals to 8x divides 2x plus 3 minus 6x plus 5. We need to put 1 by 1, minus 1 by 2 and minus 5 by 2. Let me put x is equals to minus 1 by 2. So y value is 8 into minus 1 by 2 divides 2 into minus 1 by 2 plus 3 minus 6 into minus 1 by 2 and plus 5. So y would be equals to 8 into minus 1 by 2 negative 4 divides 2 is cancelled with 2, negative 1 plus 3. This is plus 2 times 3, 6 plus 5. Further simplification, y would be equals to minus 4 divided by 2 plus 5, 6, 7, 8. And this is 2 times 2 plus 8, that is equals to 6. When x value is minus 1 by 2, the y is 6. This is the first x coordinate. Coordinate of the stationary point. When the x is minus 1 by 2, the y coordinate is 6. Right? Now let me put the second one. When x value is minus 5 by 2. Right? So y is equals to 8 minus 5 by 2 divides 2 into minus 5 by 2 plus 3 minus 6 into minus 5 by 2 plus 5. Okay. Now here 2 times 1 is 2, 2 times 4 is 8, and 4 times minus 5. 8 times minus 5 over 2, negative 20. Y is equals to minus 20. Divides 2 is cancelled with 2, minus 5 is left plus 3. 2 times 3 is 6, minus minus plus 3 times 5 is 15 plus 5. So here y would be equals to negative 20 over negative 2 plus 20, because 15 plus 5 is 20, and from 5 take away 3 is negative 2. Negative is cancelled with negative 2 times 10 is 20. So y is equals to 10 plus 20. So this y coordinate is 30. Right. Now the second coordinate of stationary point, when x value is minus 5 by 2, the y value is 30. This is your second coordinate of the stationary point. This is the second one, and that's the first one. We need to figure out the coordinates, the x and y coordinates of the stationary points. Now for question number 4, the diagram shows the part of the curves with equation, this equation and this equation, the part of these two curves. Okay, and point P is a point of intersection of the curves, and the shaded region is bounded by two curves and the y-axis, these two curves and the y-axis. Okay, part A show that the x coordinate of P, x coordinate of the point of intersection, satisfies the equation, right? So for x coordinate, we need to figure out the point of intersection of two curves. Okay, for point of intersection of two curves, we need to put both of them equal. So 1 plus 0.5 sine of 3x would be equals to 4 e to the power minus 2x. Okay, to solve for x, as you guys can see, we have this thing is in natural log, right? So first of all, divide everything by 4, right? This term is dividing by 4, this is dividing by 4, and this term is dividing by 4 on both sides. So what is 1 by 4? 0.7, 0.25. 0.25, and what is 0.5 divided by 4 is 0.125. 0.125 of sine 3x, and this is equals to e to the power minus 2x, right? Now taking log on both sides, natural log of 0.25 plus 0.125 sine 3x is equals to natural log of e to the power minus 2x. So power comes before the log. Natural log of 0.25 plus 0.125 sine 3x, this would be equals to minus 2x natural log of e. Natural log of e is always equals to 1. Okay, now we are left with natural log 0.25 plus 0.125 sine 3x. This would be equals to minus 2x. Now to solve for x, we have to divide everything other side by minus 2. Minus 1 by 2 natural log 0.25 plus 0.125 sine 3x. This would be equals to x. Now my x coordinate, we can say natural log of 0.25. If I can compare both of them, you guys can see the 1 by 2, we can say 0.25, right? So the x coordinate is negative 0.5 natural log of 0.25 plus 0.125 sine of 3x. This is your x coordinate. This is proved that the x coordinate of the point of intersection of two curves. Now moving to part B, use an iterative formula based on the equation in part A. This is equation in part A, right? Find the x coordinate of P correct to 4 significant figures. Use an initial value of 0.5 and give result of each iteration to 6 significant figures. Okay, let's make an iterative formula. So the iterative formula is, we can say the iterative formula is x subscript n plus 1. This is equals to minus 0.5 natural log 0.25 plus 0.125 sine 3x subscript n, right? And we have given the initial guess, which is x naught. We have given x naught is 0.5. Now we have to figure out the values, right? N is equals to 1 when you put n equals to 0. This n is 0, so when n value is 0, so we have x 0 plus 1 is x1, which is minus 0.5 natural log 0.25 plus 0.125 and sine 3x naught. X naught is 0.5, right? Okay, let me write this down. So this is sine of something, right? So this is 0.5. So this sine, you can, now you're confused at whether the angle is in radians or in degrees. So this 0.5, 3 times 0.5, this is better to convert it into radian mode, right? Okay, let me simplify. For radian, minus 0.5 natural log 0.25 plus 0.125 multiply sine 3 times 0.5 bracket of sine and the bracket for natural log. This is up to 6 significant figures, 1 2 3 4 5 6. Okay, 0.49832. This is 0.49832. Now for the next iteration, we can say when n is equals to 1, n is equals to 1, we can say x 1 plus 1 is 2, negative 0.5 natural log of 0.25 plus 0.125 sine 3x1. This is your x1, right? So here we can say sine of answer. And up to 6 significant figures, 0.49121. 219 turns to 220, right? 1 2 3 4 5 6. This is a 6 significant figure. This is 8, so it's 19 turns to 20. 2 and 0. Okay, now the next iteration, we can say when n value is 2, n is equals to 2. We have another iteration. Let's do, and x3 would be minus 0.5 natural log 0.25 plus 0.125 and sine of 3x2. This is a value for x2, right? So let me put the answer here, and this would be 0.491200. Okay, let's me do one more and then we can guess the answer. For n is equals to 3, the third iteration, the fourth iteration basically. So x4 would be minus 0.5 natural log 0.25 plus 0.125 sine of 3, x value is x3. This is your x3, and let me put this answer, and this is 0.49120, shifted to 2 because it's round up, right? Now these are the iterations, the results of the iterations are 6 in 6 significant figures. We need to figure out the x in 4 significant figures. Okay, now we can easily guess the value of x, right? So we can say the x coordinate of p is x is equals to 0.490. 1 2 3 4 significant figure, 0.494949. This is a constant, right? Now 1 is also constant and then 2 is constant, right? 0.4912. This is the answer up to 4 significant figures. Okay, now we can say the x coordinate of this point P is 0.4912, and this would be equals to 0, right? Now for part C, hence find the area of the shaded region. Give your answer correct to two significant figures. Okay, area of the shaded region. This is a shaded region, right? So area of a shaded region, we have to integrate the upper curve from 0 to 0.4912, subtract the integration of the bottom curve from 0 to 0.4912. Now we don't know which one is the upper curve and which one is the lower curve, whether exponential or whether the sine curve. So here the x value is 0, right? We have some y value over here and some y values over here. So when you fix x is equals to 0 in this curve, right? 4 and we have 4 e to the power minus 2 times 0 is 0. So this is just 4. The y coordinate is 4. Let's say this y coordinate is 4. So this curve is y equals to 4 e to the power minus 2x. And if you put x equals to 0 over here, 1 plus 0.5 multiply sine 3 times 0. This is 1. This is 1. So this bottom curve is your y equals to 1 plus 0.5 sine 3x. Okay. Now we have to integrate the upper curve from 0 till this limit, subtract the integration of the lower curve from these two limits. That would be the area of the shaded region. I hope this is clear now. So here we can say the shaded area integration from 0 to 0.4912, right? The upper curve is 4 e to the power minus 2x dx minus integration from 0 to 0.4912 of the lower curve, which is 1 plus 0.5 sine 3x dx. All right. So first we have to figure out the integration. Area becomes 4 e to the power minus 2x divided by minus 2 from 0 to 0.4912 minus this integration x integration, one integration is x minus plus 0.5 is a constant term, sine integration is minus cos, its integration is minus cos 3x, and 3x integration derivative is just 3 divided by 3 from 0 to 0.4912. 4 is a constant, e power minus 2x is e power minus 2x, and minus 2x derivative is divided in the denominator. 1 integration is x, 0.5 is as it is, sine 3x integration is minus cos 3x, and 3x derivative is 3 in the denominator. So simplify, the area becomes minus 2 e power minus 2x from 0 to 0.4912. Subtract, we have x, and what is 0.5 divided by 3? 1 by 6 minus 1 over 6 cos 3x from 0 to 0.4912. Okay, we need to find the area up to two significant figures. Now we have to apply limits. Okay, let me apply limits. The area becomes minus 2 e to the power minus 2 into 0.4912 upper limit, subtract the lower limit. So minus this lower limit, minus minus plus 2 e to the power minus 2 into 0. This is for the first function. Subtract for the second function. I'm gonna do over here. The upper limit is 0.4912 minus 1 over 6 cos 3 into 0.4912. This is upper limit, minus the lower limit is 0 minus 1 over 6 cos 0. Okay, so the area becomes, we have minus 2 e to the power minus 2 times 0.4912. Okay, and this thing plus with 2 e to the power 0. Okay, 1.25, 1 2 3 4, up to 4 significant figures, 1 2, 4 decimal place, 2 5 and 1 2, and subtract. Simplify this one first. Let me simplify this expression. 3 times 0.4912 is this much, and cos of answer times 1 over 6 and times minus 1 and add 0.4912. Okay, 0.4750, and this term is cos of 0 is 1. 1 times minus 1 over 6 is minus 1 over 6, and this is plus 1 over 6. So plus 1 over 6 add up with 0.4750. Okay. So area is 1.2512, and subtract this much, 0.3083. 0.3083. Okay, 1.2512, subtract answer. So area is 0.942866. Sorry, I did the mistake in this part. 0.4750 plus 1 over 6. This is 0.64166. 0.64166. And if you do 1.2512 subtract with this number, 1.2512 subtract answer, this would be 0.6095. 0.609 and 5. And we need to find the area correct to two significant figures. Okay, so the area up to two significant figure is 0.9616, and this number rounded to 1. So this is the answer in two significant figures. 0.61 square units is the area. Sorry about this error. Question number 5. The polynomial p of x is defined by, this is the polynomial where a and b are unknowns. Where a and b are constant, it is given that 2x minus 1 and x minus 3 are the factors of p of x. Part A, find the values of a and b. If these are the factors, it means when you put polynomial, when p of that x should be equals to 0, right? So we can say that given that 2x minus 1 and x minus 3 are factors of p of x. If they are the factors of p of x, then we can say 2x minus 1 equals to 0. And when you can put x minus 3 would be equals to 0. From here 2x is equals to 1 and x is equals to 1 by 2. And here the x value is 3, right? This implies p of 1 by 2 is equals to 0, and p of 3 would be equals to 0 if they are the factors, right? Now just substitute in the polynomial p of x. X is replacing with 1 by 2, everything, right? A, 1 by 2 to the power 4, plus b, 1 by 2 to the power cube, plus 13, 1 by 2 square, minus 35, 1 by 2, and plus 15. This would be equals to 0, right? Okay, 1 by 2 to the power 4, 1 over 16, a, 1 over 16, b, 1 over 8, 13, 1 over 4, minus 35 over 2, and plus 15 equals to 0. Okay, let me simplify this further. So 1 over 16 is a coefficient of A, 1 over 8 is a coefficient of B, and the constant terms we can say 13 by 4 minus 35 over 2 and plus 15, 3 by 4. This is 3 by 4 equals to 0. Okay, so now we can multiply everything by both sides by 16. Multiplying both sides by 16. Why 16? Because 4, 8 and 16, every one has 16 as a multiple, right? So 16 multiply 1 over 16a plus 16 multiply 1 over 8b plus 16 multiply 3 over 4 equals to 0, right? Now we can cancel this 16 with 16, and 8 times 2 is 16, 4 times 4 is 16. Now the simplified form is a plus 2b plus 4 times 3, 12 equals to 0. This is my first equation, right? Now the second information we have given that p of 3 is also equals to 0 because this number is also a factor, right? So polynomial when x is 3 would be equals to 0. Just substitute x value is equals to 3 in this whole polynomial, right? So a, we have 3 to the power 4 plus b, 3 to the power cube plus 13, 3 square minus 35, we have 3 plus 15 equals to 0. Now 3 to the power 4 is 81. So 81 is a coefficient of A. 27 is a coefficient because 3 cube is 27 is a coefficient of B. And what is 13 times 3 square? 117. 117. And what is 35 times 3? 108. 105 with this negative plus 15 equals to 0. Now we have 81a plus 27b, and these are the constants. Let me simplify. 117 minus 105 plus 15, which is 27, plus 27 equals to 0. Okay, so can we divide it by 27? Every term is divisible by 27, yes. Divide everything by 27, 27, 27 on both sides. Okay. Now 81 divides 27 I have done, which is 3, right? 3 is a coefficient of A, 1 is a coefficient for B, and the constant term is also 1 equals to 0. 27 times 1 is 27. This is my second equation. Now you guys can see both the equation A 1 and 2 both are very simple now. Now we can easily find the values of A and B. Now here we can say from equation 1, let me solve for A, right? A is equals to minus 2b and minus 12. We can name this as equation 3, right? Now we can say put equation 3 in equation 2 to get the value for b. So this is your equation 2. Let me substitute it over here. 3 times a plus b plus 1 equals to 0. I just substitute the a value over here, right? 3 times 2 minus 6b, and what is 3 times 12? 36 minus 36 plus b plus 1 equals to 0, right? Now these are the two b coefficients, minus 6 and plus 1 is minus 5b, minus 35, 6 and plus 1 is minus 35 equals to 0. Okay, now we can say minus 5b would be equals to 35, and b is equals to 35 divides minus 5. 5 times 7 is 35. So here the b value is negative of 7. We have done with the b. Now put this b value in equation number 3 to get the a value, right? Put b in equation 3. Now from equation 3 we can say a would be equals to minus 2 times b minus 12. A is equals to 2 times 7 is 14 with positive and minus 12. So A is equals to 2. So the A is 2 and the B is negative 7. Now for part B, hence factorize P of x. So this is a polynomial P of x which we have done. A is 2 and the B is negative 7. So if I substitute the values of A and B, the polynomial is P of x is equals to A is 2, 2x to the power 4, B values minus 7 x cube plus 13x square minus 35x plus 15. Okay, I just substituted A is 2 and the B is minus 7 and the rest is as it is, right? Okay, now we need to, this is a polynomial of power 4, and we have given in the question that we have two factors of polynomial, x is equals to 1 by 2 and x is equals to 3. These are the two factors of the polynomial. So here I'm going to use a method of synthetic division. Synthetic division method. So this method basically reduce the power of the polynomial. If you apply once, the fourth power reduced to the cubic, and then again cubic reduced to quadratic, and then we can factorize the quadratic, right? So in the synthetic division method, the first step is to write down the coefficients, right? Okay, we need to write down the coefficients of x4, the coefficient of x square, the coefficient, x4 coefficient, x cube coefficient, x square coefficient, x coefficient, and the constant. Okay, and then we have given that 1 by 2 is the factor, so use 1 by 2. Okay, so in this method, we need to reduce the power to cubic. Okay, now the first step, you have to bring the first number 2 as it is. Now 1 by 2 multiplying by 2, the answer is just 1. Add them up, the answer is minus 6. 1 by 2 multiplying by minus 6 is negative 3. Add them up, the answer is 10. 1 by 2 multiplying by 10 is 5. Add them up, the answer would be negative 30. 1 by 2 multiply negative 30 is negative 15. Add them up, this is just 0, right? Now the cubic polynomial reduced, the polynomial of degree 4 reduced to the polynomial of degree 3 now. Okay, one more information in the question, we have given that it has two factors. The first one is 1 by 2, the other one is 3. So we have to use the number 3 as well. Okay, since 3 is a factor. Okay. Now we can say 3 is the factor. Write down the 3 over here. Bring the first term 2 as it is. 3 times 2 is 6. When you add them up, it is 0. 3 times 0 is 3 times 0 is 0. Add them up, this is 10. 3 times 10 is 30. Add them up, this is 0. Right. Now we can write this polynomial p of x. It has a factor 1 by 2. So we can say x minus 1 by 2 is the factor. X minus 3 is the factor, and this is now the quadratic, right? So this is the polynomial of degree 4. When we apply synthetic division once, this is a polynomial of degree 3. When we apply one more time, now this is a polynomial of degree 2. Now this is 2x square plus 0x plus 10. Okay, let me factorize it. Now the polynomial p of x, this is 2x minus 1 divided by 2, x minus 3, 2x square plus 10. Okay, now p of x is 2x minus 1 divided by 2, its product with x minus 3. Let me take 2 common. We are left with x square plus 5. So this 2 and this 2 is cancelled out, and here we have p of x is equals to 2x minus 1, x minus 3, and x square plus 5. We cannot factorize this, right? So this is in the fully factored form, the polynomial p of x. Now for part C, find the least positive value of theta in radians such that p of cot 2 theta equals to 0, right? Now we have p of x, which is 2x minus 1, and the factored form I'm using from part B, x minus 3, and x square plus 5. Okay, this is p of x, right? When you put x equals to 0, right? So p of x equals to 0 over here. Sorry. P of x is equals to 0. When p of x equals to 0, it means 2x minus 1, x minus 3, and x square plus 5. This should be equals to 0. All the factors are separately equals to 0. 2x minus 1 equals to 0, x minus 3 equals to 0, and x square plus 5 would be equals to 0. Now from here the x value is 1 by 2, here the x value is 3, and here x square is negative 5. Right, when x square is negative 5, then we have no solution from here. Why? Because when we do the square root on both sides, the square of the negative number is complex root. Square of negative does not exist, right? So we have solution from these two cases. Okay, when p of x equals to 0, you will get this. And when p of cot 2 theta equals to 0, p of cot 2 theta equals to 0, it means x is replacing with cot 2 theta. This means cot of 2 theta is 1 by 2, and cot of 2 theta equals to 3, right? So I hope this is clear now why it's not a solution, because square root of negative number does not exist, so we have no solution from here, right? Okay, so cot is basically the ratio of tangent, right? So 1 over tangent 2 theta is 1 by 2, or we can say 1 over tangent 2 theta is 3. Now to get the value of tangent, we can do a reciprocal on both sides. So tangent 2 theta is 2, the reciprocal of this and this side. And the other case is tangent 2 theta is 1 over 3. We can say this is 3 by 1. So the reciprocal of 3 by 1 is 1 by 3, right? Now here we have to figure out what is the base angle, right? So the base angle. Okay, now we do not have given any domain, right? What is a range for theta? We just need to figure out the least, and it should be a positive value of theta, and it must be in radians, right? So the base angles in both cases are 2 theta is tangent inverse of 2, and theta would be equals to tangent inverse of 2 divided by 2. Or the other hand, we can say 2 theta is tangent inverse of 1 over 3, and theta would be equals to tangent inverse of 1 by 3 divided by 2. Since no domain for theta is mentioned, we just need to figure out the positive value of theta, and that value should be the least one, and in radians, right? Your calculator should be in radians. Now tangent inverse of 2 and divided by 2, this value is theta equals to 0.5536 radians. Now tangent inverse 1 over 3 divided by 2, this value of theta is 0.1608. Okay, now which one is, both are positive, both are in radians, we need to pick the least positive value. So we can say the least positive value of theta is 0.5 or 0.1. 0.1 is the least, 0.161 radians. This one, this is also correct, but this one is not the least one, because in the question we just need to pick the least positive value of theta. So this is the least positive value of theta in radians. Question number 6. A curve has equation. This is equation of the curve. Part A, show that there is no point on the curve at which the y coordinate is e power minus 1, right? So we can say let y is equals to e power minus 1. Put this in equation of curve x square minus 3 ln e power minus 1 plus 6x equals to 14. So x square minus 3, apply the property minus 1 natural log of e plus 6x equals to 14. The power rule, right? Power comes before the natural log. This is negative x square minus 3 and ln of e is just 1 plus 6x minus 14 equals to 0. So in this step I shift the 14 over here and natural log of e is just 1 and this minus 1 shift over here. So we have minus x square plus 3 plus 6x minus 14 equals to 0. Minus x square plus 6x, and from 14 take away 3 is negative 11 equals to 0, or take the negative sign common. X square minus 6x plus 11 equals to 0. Okay, now we have to this is a quadratic equation. You can factorize it or you can apply the quadratic formula, right? So if the x values are possible corresponding to y equals to e power negative 1, it means there is a point on the curve with x y coordinate e power minus 1. If the x values are not possible, we need to show that x values are not possible when you substitute y equals to e power minus 1. It means there is no such point on the curve whose y coordinate is e power minus 1, right? So we have to use a quadratic formula x equals to minus b plus minus square root b square minus 4ac divides 2a. Okay, where is a, b, c? A is a coefficient of x square, b is a coefficient of x, and c is a constant. Okay, now x would be equals to negative of b plus minus square root b square minus 4a and c divides 2 times of a is just 1. Okay, now here the x value is 6 plus minus square root. Let me simplify. Negative 6 square is 36 and minus 4 into 1 into 11 minus 8, and 2 times 1 is 2. Okay, so root of negative 8 does not exist. Root negative 8, no solution, right? So we have no x coordinate because square root of negative does not exist when there is no x coordinate. So we just need to show. So we have showed that uh, corresponding to y equals to e power negative 1, there is no x coordinate. When there is no x coordinate corresponding to this y value, then there is no point on the curve at which the y coordinate is e power negative 1, right? Because the discriminant is negative. Okay, now moving to part B, find the equation of tangent to the curve at the point 2e and e square. Give your answer in the form of y equals to mx plus c, where m and c are exact constants, right? In this form, they are an exact constant and equation of tangent. All right. So for equation of tangent, we need two things: the gradient of the curve and the point. So the point is already given. Just find out the gradient of the curve, right? Okay, so the gradient of the curve, we have to differentiate the curve. D by dx of the whole curve is x square minus 3 natural log of y plus 6x minus 14 equals to 0. I shift the 14 on the other side, right? So we need to differentiate this basically. Okay, so here we do the product rule. X square minus 3 is as it is, derivative of the second function, plus the second function is as it is, d by dx of the first function, plus 6 is a constant, d by dx of x, and 14 derivative is just 0. So here we have x square minus 3, ln of x derivative is 1 over y dy over dx, plus ln of y is as it is, this derivative is 2x plus 6 equals to 0 because dx over dx is just 1, right? Okay, x square minus 3 divided by y dy over dx equals to minus 6 minus 2x ln y. I combine the dy by dx term and the constants are on the other side, right? Okay, further simplification, we have dy over dx. This is minus 6 minus 2x ln y divides x square minus 3 over y. This term divides in the denominator, right? So this is a gradient. Now we need to figure out the gradient at this point, 2 and e square, right? So we can say what is at the point 2 and e square. Dy over dx, gradient of the curve at the point x coordinate is 2 and the y coordinate is e square, minus 6 minus 2 x coordinate is 2 ln e coordinate y coordinate is e square, whole divides x coordinate is 2, 2 square minus 3 divides the y is e square. Okay, now we have dy over dx at 2 and e square. This becomes minus 6 minus 4 natural log e square, multiply, this is a reciprocal, e square divides 4 minus 3. Okay, now dy over dx to e square, we have minus 6 minus 4, this comes before the log, natural log of e square over 1. Okay, natural log of e is just 1. Minus 6 minus 4 times 2 is 8. Natural log of e is 1. So this whole thing is multiplying by e square. So we can say minus 6 and minus 8. This becomes minus 14 e square. This is negative of 14 e square. This is the gradient. Okay. Now we can easily find out the equation of tangent. Equation of tangent at the point 2 and e square, which is y minus y naught is equals to the gradient of the curve into x minus x naught. This is a gradient of the curve at this point. Okay, so substitute everything. We have y minus y naught is e square equals to m values minus 14 e square, x minus x naught is 2. We need to convert it into y equals to mx plus c form, right? Okay, so y minus e square, this is minus 14 e square with x and minus 14 e square with negative 2. So here y is equals to minus 14 e square x and minus times minus, what is 14 times 2 is 28, plus 28 e square, and shift this e square on the other side at positive 28 e square. So y is equals to minus 14 e square with x and plus 29 e square. This is in the form of y equals to m x plus c. This is a value for c and this is a value for m. Now we have proved it. This is in y equals to mx plus c form. Question number 7, part A. Express 4 cos theta sin theta plus 30 degree in the form of r cos 2 theta minus alpha plus k, where r is greater than 0 and alpha is between 0 and 90 degree and k is a constant. Okay, so we have 4 cos theta sine of theta plus 30 degree. This should be in the form of r cos 2 theta minus alpha plus some k. We need to solve for k, which is a constant. Alpha should lies in the first quadrant, 0 to 90, and r. Okay. So here we have to open the double angle formula for sine a plus b. Sine a plus b. This is equals to sine a cos b plus cos a and sine b. And double angle formula for cos a minus b. This is cos a cos b. It's minus or plus sine a sine b. Okay, let me open these two formulas. 4 cos theta is as it is. Sine theta plus 30 degrees sine a plus b. Sine a cos b. Sine theta cos 30 plus cos theta sine 30. This whole thing equals to r bracket cos a minus b. Cos theta cos alpha plus sine theta sine 2 theta sine alpha plus some k. Okay, now for this simplification we need to figure out sine 30 and cos 30. This is in radians, convert it into degree. Cos of 30, okay, 4 cos theta sine theta. Cos 30 is square root of 3 divided by 2 plus cos theta sine 30 1 by 2. This thing equals to r cos 2 theta cos alpha plus sine 2 theta sine alpha bracket plus some k. Further simplification, we can say product, right? Cos theta sine theta root 3 by 2 multiply by 4. 2 times 1 is 2, 2 times 2 is 4. So 2 square root of 3 cos theta sine theta. Okay, and this should be in cos square. 2 times 2 is 4 plus 2 cos square theta. This is r cos 2 theta cos alpha plus sine 2 theta sine alpha plus some k, the constant. Okay, now we have to compare the coefficients, right? But before comparing the coefficients, we can see this here. We have cos 2 theta and sine 2 theta, because we need to solve for alpha, r, and k. So we need to compare the coefficient of cos 2 theta and sine 2 theta. But there is no cos 2 theta and sine 2 theta. We have to convert it into that form. So what is the formula for sine 2 theta? Sine 2 theta is 2 sine theta cos theta. So this is 2, this is sine theta, and this is cos theta. We can make 2 sine theta cos theta, this term, as sine 2 theta with square root of 3. Yes, we can do this. Square root of 3 and sine 2 theta. Okay. And the other thing we have is cos square. We have to convert this into cos 2 theta. We know that cos of 2 theta is also equals to 2 cos square theta and minus 1. So 2 cos square theta is cos 2 theta and plus 1. This is cos of 2 theta plus 1 equals to r cos 2 theta cos alpha plus sine 2 theta sine alpha plus some k. Okay, now we can simplify this further as well. So square root of 3 sine 2 theta plus cos 2 theta plus 1 equals to r cos 2 theta cos alpha plus r sine 2 theta sine alpha plus k. Now compare the coefficients. And at this stage we can compare. Comparing the coefficients of sine 2 theta. Start with sine 2 theta. Sine 2 theta here is square root of 3. And over here sine 2 theta is r sine alpha. Okay. The next coefficient we need to compare is cos 2 theta. Cos 2 theta coefficients are, this is just 1 over here, and r cos alpha. And we need to compare the coefficients of constant. So the constant's coefficient here is 1 and here is k. So we have done with the k value. K is equals to 1, right? So the k value is done, that the k value is 1. Now this is your first equation and this is your second equation. In r and alpha you have to square and add the two equations to get alpha and to get r, and then divide the two equations to get alpha. So here we can say squaring and adding equation 1 and equation 2. Okay, let me square. This is r square sine square alpha plus r square cos square alpha equals to root 3 square is 3 and 1 square is just 1. So we can take r square common. Cos square alpha plus sine square alpha, this is equals to 1, and 3 plus 1 is 4. So r square is 4. To get the value for r, take a square root on both sides, and when we do the square root it is plus minus. So the value of r is plus minus 2. Since we have given that r should be greater than 0, so we have to pick only the positive value, right? So we can say, given that r is greater than 0, this implies the value of r is 2. This is a value for r. Now to get the value for alpha, we can divide equation 1 on equation 2, right? Dividing equation 1 and equation 2. So r sine alpha over r cos alpha. R sine alpha divides r cos alpha. This is square root of 3 divides 1. Root 3 over 1. R is cancelled with r. Sine alpha over cos alpha is a ratio of tangent alpha, which is equals to square root of 3. So what is alpha? Tangent inverse of square root of 3, and this is in degrees because alpha should be between 0 and 90 degree, right? 0 is less than alpha is less than 90 degrees. Okay, my calculator is in degrees. Okay, tangent inverse square root of 3 is 60. So alpha is 60 degrees, right? So we can express that form: 4 cos theta sine theta plus 30 degree equals to r cos 2 theta minus alpha plus k. Okay, how do we express it? So we can say this is r value is 2 cos 2 theta minus alpha is 60 degree, and the k value is 1. So this is how we have to express the form. Now for part B, hence solve the equation. This equation equals to 5 and phi should be equals to 0 and 90 degree on the first quadrant, right? So if I make a comparison with the first equation for, okay, let me make this, write it down. From part A, we know that 4 cos theta sine theta plus 30 degree, this should be equals to 2 cos 2 theta minus 60 degree plus 1. Okay, now here we have, it's not 2, it is 12, and theta is 2 phi, this theta is also 2 phi, and this is 30. So here we can let theta equals to 2 phi and multiplying by 3 on both sides. Multiplying by 3 on both sides, 3 product with 4 cos theta is 2 phi sine 2 phi plus 30 degree, 3 product with 2 cos 2 times theta, 2 and theta is 2 phi minus 60 degree plus 1. Okay, this becomes 12 cos 2 phi sine 2 phi plus 30 degree. This is equals to 6 cos 4 phi minus 60 degree plus 3. 3 times 2 6, 3 times 1 is 3, right? So now this whole thing, if I compare 12 cos 2 phi sine 2 phi plus 60 degree, is this term equals to 5. This whole thing equals to 5, right? Compare with the question. So when we make a comparison with the given question, we come to know that 6 cos of 4 phi minus 60 degree plus 3 should be equals to 5. And we have to solve for phi, and phi is between the first quadrant. Okay. Let me simplify now. 6 cos 4 phi minus 60 degree. This would be equals to 5. Take away 3. Now cos of 4 phi minus 60 degree is, this is 2 divides 6. 4 phi minus 60 degree is cos inverse of 2 times 1 is 2, 2 times 3 is 6. Okay, cos inverse, this is in degrees, right? Cos inverse 1 over 3. 4 phi minus 60 degree is 70.53 degree. Okay, after that equation, we know that the phi is from 0 to 90. So what is a range for 4 phi? If theta 0 degree is less than phi is less than 90 degree, then 0 is less than 4 phi is less than 4 times 90, right? So everything is multiplying by 4. 4 times 90 is 360 degree. It means the 4 phi should be lies between 360 degree, right? Now this is a whole base angle, right? This is a base angle. Base angle is 4 phi minus 60 is this much, and this is for cos. And this equation tells us that cos is positive. Now from 0 to 360 degree, cos is positive in first and in fourth quadrant. Let me draw the coordinate diagram and show you guys that cos is positive in which quadrant from 0 to 360, right? So in the first quadrant, all trigonometric ratios are positive. In second quadrant, sine is positive. In third, tangent is positive. And in the fourth quadrant, cos is positive. Since now the domain for 4, 5 is 0 to 360. This is 0 degree. This is 90. This is 180. This is 270, and then again this is 360 degree, right? From 0 to 360, cos is positive in the first and in the fourth quadrant. First quadrant is the base angle, right? And fourth quadrant we do 360 degree minus that base angle. BA is for the base angle, right? Now this equation tells us cos is positive, so we know that cos is positive in which quadrants. Okay, so we can say that cos is positive in first and fourth quadrant. Okay, now we need to solve the answers for the first quadrant. So for the first quadrant, it is base angle, right? So this whole angle equals to the base angle, right? So we can say 4, 5 minus 60 degree is equals to the base angle, and we have done the base angle, which is 70.53. Base angle is 70.53. Let me solve for 4 pi. Phi is 70.53 plus 60 degree, and 5 would be equals to divided by 4, right? Let me simplify. 70.53 plus 60 is 130.53, and divided by 4, so this thing divided by 4 is 32.6. Phi is 32.6 degrees, and this value of phi is between 0 and 90, right? And cos is also positive in the fourth quadrant. So what is answer for the fourth quadrant? The angle is equals to 360 minus the base angle. So 360 degree minus this was with the base angle 70.53. Okay, so 4 phi would be equals to 360 minus 70.53 is 289.47, 289.47, and then add 60, shifting the 60 on the other side is this much. So 5 would be equals to 349.747 divided by 4, 349.47 divided by 4. The other value of phi is 87.4 degrees. So this is the phi, which is 87.4 degrees. So this value is also in the range from 0 to 90 degree, right? So these are the two solutions. Phi is 87.4 degree, and we can say phi is 32.6 degrees, and these two are in the range from 0 to 90 degree. So in order to get the two solutions, you have to check your domain, right? So the domain is for phi, which is from 0 to 90, but in the question we have the angle 4 phi, so we have to figure out what is the domain for 4 phi, which is from 0 to 360. The domain for 4 phi is now from phi is from 0 to 90, for 4 phi 0 to 360. So you have to solve that 4 phi from 0 to 360, and then find out the final answers for phi, right? I hope this is clear now. So that was the last question of our paper. If you have any queries, please let me know in the comment section, and please subscribe to my channel. Thank you for watching. See you next time. Take care.